Today we're going to be delving further into data structures and how you represent the data for particular classes of problems. And we're going to start by just looking at the real simple problem of how would you represent a circle that is centered at the xy coordinates 1.2, 0.8 with radius 2.2. And one idea is that you could create a list like this and have the x and y coordinates as the first two elements, and the third element is the radius. And then anytime you went to do computations with your circle, maybe you wanted to compute the area, you would need to remember that the radius is at index position 2, so you would have code that maybe looks like this. Now, if you have a long code and you're doing many things with circles, perhaps you will remember that the meaning of this is accessing the radius out of this list of 3 values, but someone else that sat down and looked at your code might be a little bit puzzled about what you're doing. Are they using the radius? Are they using the diameter? What are they trying to do with these various computations? So maybe one strategy would be to set up some constant variables and perhaps denote that iRadius is the index to access the radius out of this computation. And now, instead of having a bunch of 2's floating around all over the place, I would have iRadius. And it might be a little bit more clear to someone that, oh, they're accessing the radius number out of these list of values that parameterize the circle, and they're computing the area here. Now, of course, if you are computing the area a number of times, the way to avoid redundant code is to create a function. So you might have a function defined like this, and now I could put that code into a function. And again, it would be fairly clear to someone if they saw a piece of code like this that, hey, they're taking their list and there's this function that computes the circle area and the value that is returned is the area. However, there's other strategies that one might consider given their knowledge of Python data structures. So for example, maybe you don't like remembering all these numbers and what corresponds to what. So here's an alternate strategy. Maybe I could use a dictionary. And again, I'm representing the same circle, except for this time, instead of 0, 1, 2, etc., I can use a little bit more descriptive values as my keys. And now I have a dictionary that represents this circle. And if I want to compute the area of the circle, I can use R in place of 2. And now someone looking at this would maybe be more inclined to understand that R is being used to access the radius for this circle. However, Python, as well as a number of other languages, support something called object-oriented programming, and you've had some interaction with the concept of object-oriented programming when you do file I/O, for example. So if I wanted to write a list of numbers to a file, I might have a line of code like this to call the open function and return a file object. Well, what is a file object? That's really an abstraction that represents all of the things that are necessary to represent a file. What's its name? Have you opened it for read or write? In addition, it has what are called the methods that are accessed via dot notation. And so you can kind of think about the file object as a very specialized object that is tailor designed to do file operations. And in the same way with object-oriented programming, we can create our own objects, such as a circle object, to more conveniently express and work with our code.